how would you solve this problem? Alex is 20 years old and begins to deposit $500 at the end of each month into an IRA account, or an individual retirement account, that pays 5% compounded monthly. So how much money will Alex have in his IRA if he decides to retire at age 60? So first, we need to know what formula to use. We could use the formula that will help us to calculate the future value of an annuity when the deposits are made at the end of the month as opposed to the beginning of the month. So the formula that we need to use looks like this. A is equal to P times 1 plus R over N raised to the NT minus 1 over R divided by N. Now you might see a lot of different variations of this formula, but if the deposits are made annually, just remember N is 1, so the formula that you see will be much simplified than the one that's on the board. So in this problem, N is going to represent how many times you're going to receive interest in a year. Since it's compounded monthly, that 5% interest is going to be paid out through the 12 months in a year. So N is 12. Now R is going to be the interest rate. So we need to convert the percentage to a decimal. 5% is 0.05 as a decimal. You got to divide that number by 100. Now T is the time. So he begins to make the deposits when he's 20 years old, and he's going to continue to do so until age 60. So he's going to do this for about 40 years. So T is 40. Now the last thing we need to know is P. In this problem, P is going to be the deposits that he makes at the end of each month. So P is 500. So now we can plug in everything. So we have 500 times 1 plus R. R is 0.05 over N. N is going to be 12 in this example, raised to the 12, or NT, so 12 times 40, minus 1 divided by R over N. So that's 0.05 divided by 12. Now, when typing this in your calculator, make sure to put this in parentheses. Now you can plug this all at once, but for those of you who may not be getting the answer, I'm going to do this one step at a time. So let's start with this part here. 1 plus 0.05 over 12. You should get this number, 1.00416 repeating. 12 times 40, that is 480. .05 divided by 12, that is 0.00416 repeating. So let's go ahead and plug this in. All right, so I got $763,010.09. The exact answer should be 8 cents because when you use this, if you don't put enough sixes, it'll change this number. When you plug it all in from the beginning, it should round to 0.08 as opposed to 0.09. So that's going to be the account value at the end of 40 years. So now let's move on to part B. What is the total amount of interest that he should receive during this time period? So in order to get that answer, we need to determine how much money he will put in over this 40-year period. So the total number of deposits that he's going to make in this time period is going to be the value of each deposit. This is made per month times 12 months. So that's how much money he's going to put in 1 year, and then times 40 years. So in the course of 40 years, he's going to put in $240,000 into this account. But this is going to be his total value at the end of the 40 years. So if we take the difference, that's going to give us the total interest that he's receiving. It's going to be the future amount minus all the deposits. So $763,010.08 minus $240,000. So that's going to be $523,000. Well, $23,010.08. So that's how much interest he's going to receive over the course of 40 years if he has an IRA that pays him 5% interest compounded monthly. Now granted, the higher the interest rate, the more money that he's going to receive in interest, so it pays to shop around. For those of you who want to see more finance related videos, drop a comment below this video and let me know specifically what type of videos in the areas of personal finance that you want to see. So feel free to do that when you get a chance. Thanks for watching.